Welcome to my talk about micro frontends and how to build them with module federation. First of all, thanks for Dynatrace for hosting everything here. I'm really glad I can be here and show you some things we did and found out in the last few years. So if you want to have the slides of this talk, you can take a photo now. In the end, you will also get the QR code, or you can just do it analog and just talk to me, and I will give you the link. We will start with a quick overview about micro frontends. Why do we use them? Later on, we will follow up with a live demo. So we will use a monolith, make it split it up into 3 separate micro frontends and introduce module federation here. And finally, I want to highlight challenges and difficulties we had with micro frontends and module federation in the last 2 years. So quick few words about me. I'm Ganster. I'm co-founder and full stack developer at devaholics. And I've been building now or working in a JavaScript ecosystem in the last 10 years. I've worked with TypeScript and several front-end frameworks, but my focus in the last few years has been React. I've also worked with Spring Boot now for some years, which is why I consider myself a full stack developer more. But with module federation, to be concrete, I've worked the last 2 years intensively with. You can find me on LinkedIn, and you can also find me on email, and you can also find me here. So let's start with a quick question. Why do we use micro frontends? So what's the purpose here, more or less? So to answer that question, I came up with a quick fictional story about a company called EstateMate. So EstateMate is essentially Willhaben, ImmoScout24 or Zillow clone. So what they do is they are a real estate platform. So in this fictional story, they list properties, they show some advertisements, and they do some user management like login, logout, and stuff like that. I even came up with a logo for them. As you can see, it's not AI generated. It's crafted by hand in 10 seconds in GIMP. And maybe because of that logo, they became very successful. And they needed to scale up. And EstateMate, everything is in a monolith currently, and there are now several options to address the scaling problem and how they can split this monolith up more or less. So this is the current state. As you can see, EstateMate has one big repository with one big code base that contains the front end, the back end, the database. So essentially, this is simple and manageable. And everyone in EstateMate knows everyone, and everyone knows everything. But to scale up, we need to find some split points here. One option, obviously, split by front and back end. And another option would be to split up by microservices. So for example, you will have a team dedicated working for the property microservices, one for the ad microservice, or one for the user. And on top of all that, you have one front-end monolith. But for complex single-page applications, such as front-end monoliths may still become difficult to maintain, which is exactly where micro frontends come into play. So for micro frontends, you can view a web app as a composition of features, and you have independent teams working with independent tech stacks and independent repositories. And all of these teams try to solve different missions. So for example, you have team property, which want to achieve users so they can find and view listings of certain properties. Team ad wants to increase ad revenue. Team user wants to have secure app and login and stuff like that. And all these teams build their features from end to end. So they build the front end, the back end, the database, they do the hosting, and more or less you have one vertical split through team. To achieve this, there are several options to do this. So first and foremost, you have module federation, which is the focus of this talk. You can also do like some kind of traditional approach by simply injecting script and doing the module loading by yourself. Then you also have native federation, which is more browser native and tooling agnostic and utilizes this import map, where you map to the CDN. Out of completeness sake, we also have here Pyrel and Luigi, but I have not worked with them, but at least I found them, that there are also tools for that. But in the end, the challenges at the end I will show will look quite similar, no matter what tool you will choose. So for module federation, I want to establish like a common ground here in this room. So I want that everyone knows the terminology when we do the live coding. So on the left-hand side, we have the consumer. And the consumer is an app that wants to load another app. That's called the producer. So the consumer loads the producer. And to know what is actually exposed by the producer, a module federation coined the term exposure. So you expose and some component that the consumer wants to load from the producer. And to know where to actually look like in the World Wide Web, you have a list of remotes on the consumer side. So the consumer knows, okay, if I want to get something from app 2, I need to look at that URL. And now the fancy stuff about module federation is you have a normal import from some module, but the cool thing is it looks literally the same as you would import any other module, but module federation hides all the network traffic during build time. So what you do if you call this import line, module federation in turn in the background fetches some sources, fetches JavaScript, and more or less invisibly transfers the import to actual HTTP calls in the background that the browser will do. And besides sharing this code across multiple JS applications and micro frontends, it can also share resources and dependencies. So for example, React as a dependency, you don't want to load 10 times if you have 10 apps, which is why module federation enables you to load it once and distribute it across all apps. It also gives you type generation. So if a producer says, I'm exposing app component X with properties Y and Z, it tells you exactly what properties needs to be defined. You're completely type safe here. But one thing to note, it has nothing to do with rendering. So in module federation, any module can be exposed. You can expose a function, a component. It doesn't matter. It doesn't need to be React. It can be anything. So this means the rendering is up to the developer. So they can render it in the same React route. They can render it into a DOM element. They can render it as a web component. It really doesn't matter. Module federation is solely responsible to load more or less and share dependencies. And now, before we jump into the live demo, I want to quickly show you what we are going to, or what we try to achieve here. So first, as in the previous slide, we will have a monolith that has everything in there. And afterwards, I want, together with you, have 3 micro frontends split. So we will have a property app, an ad app, and a user app. So this is how the app currently looks like. As you can see, you have some properties here, you have an ad, and you have like the user management. So the first layer will be the advertisement app, because as you can see, it shows more or less an advertisement for a moving company. Then you have the property app that already does more. So it loads the properties, shows them to the user, and in turn includes the ads somewhere between the properties. And the final layer will be the user app. The user app also scaffolds everything and does login, logout, showing names, and stuff like that. The tech stack we are going to use will be React as a front end, but module federation works with Vue, it works with Angular. And as a bundler, I've chosen RSBuild because RSBuild has quite a nice module federation integration. But in the end, it doesn't matter because you will see RSBuild is quite similar to Vue, and there are also plugins for Vue, plugins for Webpack, but RSBuild is more or less where everything started with module federation. Or it started with Webpack, but it has a nice integration now. And for backend, we will have nothing. So we'll have just a dummy backend in the end. Good. In that case, let's get right into it. So let's open everything. Perfect. So here I have the app already open, up and running. And what I really want to emphasize here before we start with the demo is StateMate already made one important step before introducing micro frontends, which is establishing clear domain borders in your code. So as you can see here on the source, I hope it's big enough. You have more or less advertisement, property, and user already split up in some tiny modules. And on the right-hand side, you also have a clear split. So you have the ad app here, the properties outside, more or less what you've just seen before. And now, what I'm going to do is I'm going to pick this monolith, introduce all module federation plugin settings, and then we are starting to split it up. So For that, I've opened now the module federation setup guide here for us. So basic create React app with RS build. So you're going to scroll down. Oh yeah, never mind. I also need to click it. Good. Step 1, create React project that we already have. Step 2, installing module federation. Let's go. So we are adding now module federation, and as a version, I'm going to use a fixed one because the newest minor version has a bug. Thankfully, I tried everything out yesterday, which would have cost us some time now, but this will be now a little bit faster. So now we're also going to add the plugin at 19.1. Good. And now, step 3, update the entry files. So what do they want us to do? Rename index to bootstrap. Great. So we're going to pick the index file here, call it bootstrap. That's easy. If my PC responds, there we go. Perfect. The content should look like this. So let's have a look. Yeah, we render in some React root. Looks familiar. And now create an index file to import the bootstrap. Perfect. Maybe let's do that. Index.tsx import bootstrap. Perfect. Amazing. So what we did here now with this bootstrap and lazy import is what module federation calls an async boundary. So you more or less, module federation needs your index to be there immediately, and all the rendering needs to be behind lazy import. And this is just a requirement of module federation. And the guide tells us to do so, we'll do it. And now to the more interesting part is actually adding the module federation plugin to our bundler. So as you can see here, it looks a little bit familiar with Weed. We already have the import here from the dependency. Yep, pick that one. And as a name, let's pick a statemate to do, because that's still the monolith and we will split it up later. What we also need, and this is because the tsconfig setup is defined here, is to give the type generation of module federation a hint what tsconfig to use, because I've split it up more or less in an app and a node file to have more or less the correct typings for both, but module federation at the moment sadly isn't able to differentiate use the references properly, which is why I'm going to help them a little bit out. So type definition, generate types, and there we can say tsconfig path, tsconfig app JSON. Perfect. And now we come to the first interesting part of this plugin and one big feature of module federation, which is the shared dependencies. Because the shared dependencies now define what dependencies of our apps are we going to distribute across the module federation landscape, or more or less within the browser. So in our case, we are going to start with React as a dependency. And React, first and foremost, needs to exist only once in the page, because otherwise, a React root can't render other React components within the same root. And we're also ensuring that the app fails if multiple versions are found, because otherwise we'll only get the warning. And then in required version, we're going to set the version of React we want to have. And for that, I'm just simply going to go here, dependencies from package JSON. Great, because I'm more or less just using a shortcut here, so I don't need to know the actual React version. But as you can see, you can use one-to-one the same versioning syntax here. So if you have a caret like this, it will also work. Module federation is smart enough to find out what version fits for your app. And since we have more dependencies, we are going to add more. So maybe pick React DOM now. React DOM, there we go. And finally, I'm also going to share our component library, which in our case is aunt_d. So For those not don't know it, it's more or less same as MUI or any other component library. It just has beautiful buttons and boxes. And it saves us the trouble of building everything ourselves. That we're also going to use from the package JSON, but ANT does not need to be a singleton. It works with multiple versions present. This is more or less just something some dependencies have, as React, for example. Good. Maybe let's start it up and see if everything works and if we didn't break anything. That looks green, looks good. Refresh it. Perfect. Good. So everything is the same. Fascinating. But maybe now let's do the more interesting part, which is actually creating the microapps. So for that, I'm going to copy paste the monolith into 3 applications. So first we have the user, then we'll have the property app, and then we'll have the advertisement app. Good. Yeah, of course, I need to be in the folder. So I'm just leaving the monolith running so we have something to look at while we build the smaller apps. So first things first, let's start with the advertisement app. So to recap, what app we are going to build now. Cool. Okay, the tool splitting won't work out. Amazing. Perfect. So the app we're going to build now is this part, which is showing some advertisement, just any card, and this advertisement is the app we're going to build. So first, maybe open up the source code, and now let's just remove everything from other domains. We only care about advertisement in that app. And there's the next part. Okay, CI, there we go. Maybe let's start it up. Now it should fail, yeah. Because we are of course running on the same port as the monolith, which is why we are going to pick a different port. And of course we are going to change it from to do to something actually reasonable. Boot it up again, and now it should also fail because we of course deleted deleted user. So as you can see, we should now exchange the root page here too. And this root page is more or less only for the team of advertisement to use. So it will not be used in production code, and it will also only be used more or less as a demo and a continuous development stuff. So I'm going to pick like any ad from the ad card system. I'm going to boot it up again and have a quick look. Okay, amazing. We have an advertisement card extracted. But this is not why we came here for. Now comes another interesting part of module federation, which is the exposer. Because the advertisement app is not the producing app. This is now that produces other components. And with this exposer setting, we can actually say, okay, what are we actually exposing? Because module federation can't know that. So we are going to say, okay, we want to share the ad card, which lies at source advertisement/ad card. Wait for the build to finish. Refresh. Okay, this is a known warning. Let's see if we still have it. Perfect. And that's it. So advertisement is now federated. It has a component that it exposes. And now we're going to take, this step further and go to the next layer, which will be the property app. So keep in mind, we are now building this part here. So we are now building the property list, and as you can see, the property list will load this other app. So wait for IntelliJ to finish indexing. Perfect. So same as for the advertisement, we are now going to delete everything that doesn't belong to property app. And what we also need to do is, of course, change the port and the name. So more or less the basic stuff. I will do just right away. Boot it up, and we should get a failure right away because, of course, we're still not having the user app. We are still now in the property app. So we're looking into Bootstrap. getting rid of the user import, and now building the development page for the property team, which will be just looking at the listings, the property listings. Good. Now if you run again, another error, of course, because we deleted the advertisements. So we go to the listings page, see, okay, already get a warning here. We don't have add card, obviously. Just going to throw in some dummy component here. So blah, 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 my fancy add. So let's wait for the rebuild. As you can see, we removed now everything. There's no user, there's no add, just properties. But this is not enough for us because we want to actually show something instead of just some text. And this is now where the consumer feature of module federation comes into play. So you more or less define the remotes where the property app will look up other apps. In our case, we want to say, okay, let's look at the advertisement app. So we're defining now the alias, which I will, out of simplicity wise, just keep the same. And then say, okay, look at localhost manifest.json. So now you might already be wondering what the hell is a manifest.json or an MF manifest.json. So if we open it up in the browser, this is now 4001 is the advertisement app. And the manifest.json is like this one important entry point module federation has. So in this entry point, the property app or any consuming app essentially is able to look up, as you can see, what is it called? What JavaScripts do I need to load? Where can I find the types? Which dependencies are shared? Also important. So you have like the React, singleton setup, the required version, and finally, and most importantly, also the exposures. So we know which components we can load from there. So let's scroll here down there. And now we can already see one line in the build log. Federated types extraction completed. Behind that clunky sentence just hides a cool little feature of module federation, which is type generation. So as you can see here, in the root of our project, we now have an MF types folder. That one contains exactly this remote we just defined. And it more or less, what module federation in the background did, pick this MF types zip, extract it, and put the definition files into our consuming app. And by looking into these definitions, we are now able to build completely type safe while still communicating with an app completely somewhere else, more or less. So let's have a look in the property app, how this looks like. Yeah, it says still fancy add. That's not so fancy. Maybe actually use that. So we're going to remove this dummy part. And now, as you can see, we're just using the same import syntax, but instead of importing a file, we're going to say state mate advertisement/add card. And in theory, that would already be it. But as you can see, we're still getting type errors because TypeScript does not know module federation. TypeScript has its own tsconfig. And in the tsconfig, we only are looking into source, which is why I'm going to go here and say, OK, for every unresolved import, please be so kind and also look into the MF types folder. And by adding this mapping, we can see import is done. And the cool thing, if we go where it's actually used, you can see we have the property typing. So TypeScript says, OK, the definition file says add counter must be a number, must be defined. And now let's see the magic in works. Crashes, amazing. Yeah, OK, hiccup, whatever. Essentially, we have now here the remote app being loaded. And if I open up the DevTools, you will already see that we have, maybe let's sort it by URL. So 4002 is our property app. I hope you can read it. Let's zoom in a little bit. So you have 4002 for the property app and 4001 for the advertisement app. And this is now, if I remove the JavaScript filter, you can see we are loading the manifest.json, if we sort timing-wise. We are loading the manifest.json from 4001, and from there on, module federation knows, OK, I need to fetch this file, this file, this file, and so on and so forth. And now the properties app is now more or less done, we of course want to go one step further and go the cascade more or less one step up. So we now will look into the user app, and by that we're just going to do the same thing as we did before. So we're going to expose something here. Let's say in our case it's the listings page, and we say okay, it's in source property listings page. Let's have a look. Build should work out. There we go. Federate types extraction completed. The factory running, we don't care. Yeah, federate types created correctly. That's the important part here. The app should still run. There we have it. So the next part will be the user app. So looking at the monolith is more or less now this header, the login, the scaffolding, more or less everything around that. It's also maybe considered as a shell. So let's open it up and do the same thing as we did before. Remove everything except what's relevant for the user. So we're going to remove advertisement and property in our case. We don't need it and we don't care. Now with that removed, we will just exchange the board right away because we know we need to do that. And we also are going to change to the actual remote name. Great. Boot it up. Look at it. And we get an error. Of course, because it doesn't know anything about the listings property. So we're going to do the same thing with the remotes as we did before in the property, just now for the next consumer. So we're saying a state made property that can be found at state made property at localhost 4003. No, that's actually our place. mf manifest.json. This is now the manifest JSON of the property app. As you can see, same format. It's a standardized communication way, and we have the shared dependencies. And more importantly, we know which properties are exposed or which components are exposed. And to actually use it, maybe go to the root page and do this exact same thing again. Of course, we need to also add the TypeScript magic. So we can actually just skip that part because you already know that. So for any unresolved import, look into mf types folder, add everything. We'll also have a gander if mf types is here. Yes, it's here. So if the listings page, definitions, everything. Awesome. Now exchange this module with the federated module, statement property / listings page. Cool. Now if you save it, run it up again, Paul, log in. Hi Paul, user is here, ads are here, everything is here. And to prove that I'm not talking, more or less making things up, we can maybe just filtered by JavaScript actually. You can see first you have the user app on port 4003, then you have the property app on port 4002, and then the advertisement app on 4001. So now we're done. We have now successfully split up our monolith, and this was more or less the most basic module federation setup you can do. And what I want to do now together with you is for some parts go into a little bit more detail and show some gotchas here. First thing I want to highlight here, the resources. So as you can see, we downloaded 8.5 megabytes. Yeah, half the word more or less. And if I now go to user, go to the shared dependency setup, maybe make this a little bit smaller, and pick aunt-t and remove the sharing. That should refresh, and let's open the DevTools. So as you can see, it grew by 2 megabytes more. Because, of course, user app is now not utilizing the shared dependency pool of module federation. It has its own aunt-t, and property and add are sharing their aunt-t. Now let's go one step further. Yeah, go away. Go to the property app and also remove the sharing. And of course, looking here at the resources, when it's done loading, again, 2 megabytes more here, kind of expected. But now comes the gotcha. So you kind of would expect if I now remove the sharing from the last app to at least stay the same, because we are now not sharing authd anymore. We removed it altogether. But if I now open this here, surprise, we are the 4 megabytes. We are back at 8.5 megabytes without any sharing. What happened here? And this comes from one big limitation module federation has, which is it can't do tree shaking. So if we have a dependency like authd, the user app, in our case, would not be able to know what other apps are using from authd. So it's more or less, from a concept perspective, not possible to build a bundle without knowing what other apps may use during runtime. So if you declare a dependency as shared, you more or less disable all tree shaking. So you're more or less exposing the whole library in the share scope, which is why you need to be really, especially the less apps you have, the more careful you need to be in setting up which dependencies you want to share. If you have like 30 apps, like 30 small pieces will still be bigger than just loading it once and distributing it 30 times. It's something that needs to be considered carefully if you want to keep your bundle size at a minimum. But it's just interesting gotcha I more or less saw. And another feature of module federation, or more or less a config, is when we do lazy loading. So lazy loading on itself is because we are still just working with modules. So the cool thing is we can do anything we would do with a normal module. So this is for the non-React people. This is just how you do lazy rendering. But let's just have a callback here. And we're going to load that module, that federated module. Module, wait, import this. And then so we have some timing. We're going to do some dummy loading. So we're waiting, resolve. We're waiting, no, not 10 seconds is the one. So waiting 1 second, and then we are going to expose the module, which is the listings page. And there on the render part, we are just putting a suspense around, so we have a nice little loading screen. So fallback, just any skeleton, doesn't really matter for now. Good. Now, if we refresh this whole part, maybe also open the inspector. If we refresh the page and open it, we can see here's the skeleton and now is the app. Nothing really exciting here, because lazy loading is completely the same as if you have a monorepo. You're just importing lazily and showing a fallback. And now comes the interesting part. If I open the page, you kind of would expect to not have any communication with the producers up until the point you render it. But as you can see here, what's that? We have 4002 and 4001. So even though we are not rendering the other apps, you're already communicating a little bit with them. And this is because there is a feature or a setting in module federation that's called share strategy. So just going to write it out here. So share strategy has more or less 2 options. First, you have version first, which is the default. And with version first, because as you already saw before, the required version could be something with a caret, 19.3 or whatever. And with version first, module federation more or less looks at all the manifest in this whole module federation world, pulls everything together, and then looks, okay, at all the carets, at all the version ranges I have available now, which is the latest version from all apps I can pick, and that one I'm going to load. And this is more or less the reason why it first needs to fetch all the metadata. But if this is not something we want to have, or if we want to restrict all communication up until the point it's loaded, we can pick the strategy loaded first, which more or less means, good, if like app A has an older React version, but that still matches the version range as app B, it more or less picks the older one because it's loaded first. It's more or less first come, first served, the strategy. And with that flag in action, I'm going to open up the DevTools. As you can see, there are still 4003 only here. And if I now render it, we can see, oops, 4002 loaded and 4001 loaded. Now as a final part of the live demo, I will show you something nice, which is this federation global variable, a module federation built injects in your app. So with this variable, you have quite a good overview of what modules exist in your share scope. So for example, looking at the advertisement app, we know, okay, React is shared, and we can see it got its share from the user app. There are also Chrome plugins that render you a tree and make it really fully fledged, but I never used it because this variable is enough, and it really helps understanding more or less the behind the scenes of module federation. Good. Now, to recap, what did we see now? So first, we emphasized more or less, please modularize your monolith before introducing micro frontends. Think of domains, think of borders, because if your dependencies go haywire, you will have bad time throwing macro frontends at this. We also saw how to set up the module federation plugin, so how to define the remotes of a consumer, how to define the exposures of a producer, and what dependency share is and how it works. Finally, we did a detour with the share strategy and lazy loading, and we also saw how type generation works. Now, before I continue, I have like the challenges I had in the last 2 years. Now, I have collected and also described right afterwards, but I thought maybe let's give our brain a quick little briefer and throw out in the round if there are any questions or something you want to see in the source code. And if you have a question, please be so kind and let Philip give you the mic.
So my first question would be like, we have this exposed micro frontend manifests here, and we have to host them, or is there possibility to build it up together to make like one big thing that doesn't really need separate? Like, is there an option to bring it all back together again? Like have it separated to develop, but for like pushing it out, have one file.
So you want to have more or less your modules built independently, but when delivering it, have one finished build, right? Kind of hard, because your module federation lives in the build time. So you define your bundler, you configure your bundler, and when you have like the Vite plugin set up, it also produces different JavaScript files. It really relies on the shared dependencies to exist. What I could imagine possible being like using a different bundler for your live build, more or less just throwing it out. Never tried it, but you could use RS build for your local MF, module federation build, but use Vite more or less to get everything back together. So in short, yes, I think it would be possible, but not out of the box.
Yeah, like I was just thinking like if it would be possible to connect it like to a hydrated approach, like we have some data already pre-built or something, and like not fill all the HTML with JavaScript, but have the HTML like kind of pre-generated and then hydrated and stuff like that.
That's actually a good question. So we are thinking now in the direction of server-side rendering, right?
Yeah.
So I have one small slide at the end, so maybe just throw it out. Just throw it out right now. Blah, 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 Tailwind, we don't care, blah, blah, blah. Next.js, server-side rendering. So this is a quote I picked from the documentation. And essentially, what they are telling you, it should work out of, or they are supporting it more or less. So you have the consumer server that in turn then delegates this route processing to the producer server, and that one just does the rendering and sends back the HTML. So that's more or less the server-side rendering part of it. It should be supported, but I have not yet worked with it. So I can only tell you what I found in the docu. Any other questions?
Thank you. I feel like I'm missing a piece because like I would expected this to work like we are doing a React app, right? And normally when you do a React app, you build a bunch of JavaScript file and then you push them in a static hosting somewhere on Cloudflare or whatever, and then you serve them. Then Or you go the other approach and you use something like Next.js, and then you have a server that is running and doing stuff. But if we are still, as understood, using like static files, I want to go back to the question that Simon has, which is, why do we need multiple server for like multiple endpoints for serving static files? Can it just be a CDN?
I mean, yes. And what also could be possible is that teams just do it completely differently. So you're not like interconnected with other teams. You could have one team not sitting in the office, maybe even be an external team you have no communication with whatsoever, and it more or less decouples. So there is the possibility to more or less don't care about the infrastructure they have. You're just loading the scripts and the manifest JSON, and that's it.
Okay, but I mean, it seems a bit not like, how realistic is it of a scenario in which you have an external team that you don't talk to and they happen to use the exact same React version as you? Like,
that's also something I can show you later on, how to support multiple React versions.
Okay, yeah.
So if you want to see that, sure. And we had that exact scenario where we had an external team that wanted to upgrade to React 19 faster than we were able to. And by more or less having a decoupled way, there was more or less they just did the upgrade and we were able to load it and render it. Yeah.
Okay. Thank you.
Welcome.
So if I understood it correctly, when you're working with it, pretty much you never, because you need to have, like, if you're locally developing it, you need to have multiple local hosts that are serving all the front ends pretty much. So if you are developing in like a big company or like between multiple companies, you would probably need something like either a Docker container running serve this thing or something that is shared so that your micro frontend is pointing to that shared, because otherwise everyone needs to download every packet manager, every Angular version 5 that is using that tiny part.
If you're loading a remote app, so you could also define like their dev environment, for example. You could reference them, and their dev environment in turn would need to set up cores so it allows localhost, so more or less localhost to import it. And then you wouldn't need to boot everything up, but just pull their localhost and let module federation do the rest.
Yeah, my next follow-up was the dependency, but I guess it was already asked.
Do you have some sort of error handling out of the box if one of the services crashes?
It's more or less the same. The error handling is the same as you would do with any lazy loading. So you can catch the error. So not out of the box, no.
Okay.
Or it's more or less async imports. You need to catch them and then store this error state and then render like an error box, and you can try again. And this is small little gotcha. This is out of how the import works in the browser, lazy import works in the browser. It can't be retried even if it fails, because a failure of an import is cached. Which is why you are going to use, if you want to do something like that, you need to use the internal load remote call from module federation. That one can be retried as many times you want. This is exactly what we also did.
Okay, and a second follow-up question. Do you, in your experience, do you deploy the whole system, or do you deploy each microfrontend separately?
We deployed them completely separately. So we actually had one repo per project, and when there is a push to develop, it's deployed to dev.
Okay.
Thanks for your talk. I'm coming more from backend development background, so sorry if this is an obvious answer, but I have a security concern about this, that for development, you should have everything available probably on a publicly available server. So your code base could read those and manage the imports and stuff like that. And doesn't it create a security concern that, okay, there is a map somewhere that everyone can know what's exactly on your code base?
Yeah, so it's, it's possible to, so what we did, we had more or less one central authentication gateway where even the script import, or the scripts were fetched via the authentication gateway. So all front-end source is behind an authentication gateway. And I will show that. Actually, I've prepared another slide for that. So it's also possible to load external applications from using different authentications. Because with hooks and plugins in module federation, you're able to more or less say, okay, use this bearer token, use this cookie. So you can do it publicly, but if it's protected, you can also protect your sources.
Okay, so and the second question is that does this support singular imports? Can different modules depend on each other, or it's not acceptable?
Do you mean bidirectional imports?
Yes.
Yes, that's possible. So you more or less need the type generation to wait for each other, but then you can do it. It's not a problem.
Thanks.
Welcome.
So do you know what the build artifacts actually look like? Is it just a bunch of compiled JS files per component that you can throw on a CDN, or is it a server that needs to be running?
If you want to see, we can just have a look. So let's maybe just throw, this will be now really live. Let's just throw out the build. Because it just has JavaScript files essentially. So
you could throw it on a CDN.
You could definitely throw it on a CDN, yeah. So they look like this, static JS. As you can see, you have some minified files, and in those files, you have like this entry point that does the module federation magic.
Okay, cool.
Any other burning questions?
Philip?
Yes.
So thanks, I saw the generated JavaScript files, but my question is actually, I saw you put the URL on localhost, of course, for development, but can you swap it during runtime then for, of course, it will be on a server, or do you have to build it for each of the environments?
No, that's cool. The cool thing about module federation, what we did was build time remote registration, but it also has dynamic or runtime remote registration.
Oh, okay.
So in our case, we wanted more or less to have this, we had another team. We don't communicate much with each other, just more or less interface communication. And we wanted them, like this MF manifest endpoint, to be exchangeable. So we needed to boot up our configuration server where we fetched the config and then inject it and by runtime register the remote. You just need to make sure before you render it, it's registered.
Okay.
Yeah.
Thank you.
Have you had a look at loading times or light score? Like how does this interact with light score or website performance?
No, sorry, no idea. I've only applied it in enterprise backend applications. So this wasn't a priority. But I wouldn't know. Okay. Then we'll just use roughly 8 minutes to show you some challenges, especially because they also answer some questions we had. So first, let's start right away with how to render multiple React versions. Now, you already saw React should be defined as a singleton. How can we use multiple React versions? Well, singleton has a little gotcha, because shared dependencies in module federation live in a so-called share scope. So by default, all apps, and also the apps we just saw in the live demo, run in the literal default share scope. So singleton actually means only one version per share scope. And we utilized this feature by defining more or less a share scope for the other team that wanted to upgrade to React 19. It's not really documented. So I was a lot in back and forth with the maintainer of module federation. But in the end, he ghosted me. But the issue is still open and it works perfectly. So I kind of accepted it to work. This is how it works. So on the right-hand side, we have, let's see, team advertisement that wants to go to React 19. So they live in the React 19 share scope. And then on the left-hand side, you still have the default share scope that, let's say, still gets React 18. So you have more or less the share scope of dependencies being distributed in the default and in the React 19 place. And now we are able to actually load React multiple versions. We need to render them. And this is where the next problem occurs. Because different React versions can't render in the same root. It just doesn't work, especially if you go major version upgrades. So possible solutions to address this would be decoupling the React rendering. So one thing would be, of course, exposing web components. One thing using something called a module federation bridge, the maintainers of MF build. But you can also build this bridge directly because it's not rocket science. Essentially, instead, on the right-hand side, instead of exposing the add card, you're exposing a render function that receives a reference to a DOM element. And on the left-hand side, for the consumer, you can see they import the add bridge, and then they render it and just supply the DOM reference. And you can do that fancy with useref, but this more or less the clear cut border, and then you have like one root per version or even one root per app, whatever fits you best. With like module federation channel with other frameworks, it all boils down to the same problem. The producer exposes means to render into the DOM, any function. Like you can import any module. So for Vue, that could be a web component, also a bridge from module federation, or just again build the bridge directly, because yeah, it's not rocket science there. For Angular, the options are more limited. You still can expose web components, but this module federation setup for Angular is a little bit more complex. Yeah, if you're interested, more to that later, but that's a little bit of a rabbit hole. And on the consumer side, you just need to load the initialization code. So you need to load the module, supply the DOM element in some way or another, and you're done. Yeah, but if you start mixing frameworks, like a React app loads an Angular app that loads a Vue app with different versions, there was even a new term coined, which is called framework anarchy, which they really advised against. But as you know, everything that's possible will be done, which is exactly what we did. So we have React apps that load and render an Angular app. So I know it works, but this was its limitation. It's enterprise development, just the way it is. Another, to answer another question we had is about authentication and how to load like external applications. First foremost, course needs to be set up properly. But let's say this frontend is only reachable via authentication. So the solution would be when fetching this manifest JSON that we've just seen, you also need to include the credentials. So either a bit the bearer token or a cookie or whatnot. And the cool thing is we have runtime plugins. So on the right-hand side, you see the RS build setup. You define more or less just a file. And on the left-hand side is the magic. So we are using this fetch runtime hook. And here, the last line is more or less the magic. We just say, okay, credentials include. So more or less put everything. We are currently authenticated to if it's on the same gateway. But here we could also put like a bearer token or whatnot. So you're able to define how the manifest is fetched. Quick overview over general challenges we had. You need to isolate Tailwind. As you saw, we had 2 slides, so it's not straightforward. We also have a topic of how to share UI across all apps, because you don't want different teams to build different UIs, so your web app will just look like Frankenstein's monster. So you will need some kind of component library that's shared across all apps. State synchronization across apps is also a topic, because if you decouple it, like I've just shown you with web components, you will need some kind of interface. And finally, CSS isolation is also a topic, because if you source an app that also sources CSS, and CSS, as you know, is global in the browser if you don't do CSS modules or something like that. But that's it. Now we are done with the challenges. You can find the slides here. I've also, in this GitHub repo, added like a before state with the monolith, but on another branch, you also get the micro frontend state. So if you're interested, you can check it out. And if there are now any questions remaining, I'm glad to answer. But now we're done.
So sorry if I was just, you already answered this because I was away for the last 5 minutes. Did you already try this with Vue already?
No. I tried it with React and Angular, but Vue is quite good documented on their page. So okay. I would highly estimate that it's possible.
Okay, thanks.
Thank you for the talk. I was wondering, the technical part was very interesting, but another thing that would interest me is what are some success stories of this technology? Like, was there some project in which like having module federation and micro frontends made the developers' life a lot better? Like, should we go now and convert all of our applications to micro frontends? And where does it make sense and where doesn't it make sense?
So to be honest, I have not yet researched that. So what I know is the project where I started introducing module federation is where it was already split out in micro frontends and they had something ongoing there. Generally, from the project of the experience, I would say if there's really a separate team as we had there, it really had the benefit that we didn't need to care about the infrastructure, and we more or less were able to just import a module and render it, and they had different development cycle. They were just in a completely different department essentially. So I feel like this is, the more you're separated, the more advantage you will gain. And if your goal is to separate your teams more because, I don't know, you have an office in US and that will build something else, then I think you will gain a lot from it. But if you have clear module borders and clear domain borders and even like architecture rules in your code that enforce it, that's probably also enough. So if you're satisfied with the deployment, I wouldn't say it's like the gold solution for everything.
It's not a silver bullet.
A silver bullet, yeah.
Thank you.
You're welcome. Any other questions? Because if not, thanks a lot. Thanks for being so attentive.